We have built what I think is an unrivaled portfolio from automotive over industrial IoT, mobile, all the way to communications infrastructure.
We want to bring together the brightest minds of the industry to change this planet to a better one.
Ladies and gentlemen, please welcome Ron Martino, Executive Vice President of Global Sales for NXP.
Okay. Good morning and welcome to NXP Connects. We are back. And I want to start the discussion today. I call it a discussion, and we'll have several of them throughout the next 2 days, with NXP's purpose. NXP's purpose is to bring together bright minds to create breakthrough technologies to make the world better, safer, and more secure. And how better to accomplish that purpose than being in Santa Clara with over 1,000 of bright minds, both technical and business in the semiconductor world, leveraging that technology to make a difference in the world. It is great to be with you. It's great to have this live engagement and be back in our premier training event where we will bring you 55 hours of hands-on and meeting room education and training. The Tech Lab will open this afternoon, has over 70 demos, both from NXP and our partners, showing innovative capability that can help you solve problems. We'll enable networking opportunities that our partners in NXP have put in place throughout the couple days that we'll be together. And we will have thought leadership discussion topics, starting with my talk around the rapidly changing world and the dramatic adoption of technology. And including in that is going to be a live chat on stage, 2 innovative leaders from companies that are changing the world in a meaningful way. John Deere, changing the concepts and capabilities in farming. Insulet, having a positive impact on quality of life, helping people manage critical medical conditions by leveraging technology that changes their life. We're going to go and talk about the same technology with a panel chaired by Junko Yoshido, Editor-in-Chief of Ojo Yoshido Report. And she's going to talk about how the same technology is shaping society. We're going to go further in terms of ecosystems that need to evolve. The ecosystem around the automobile and the software-defined vehicle. What does it take to enable cars with a significant amount of software that needs to be maintained, that needs to be upgradable and configurable over time? Followed by ecosystem evolution and discussion to enable interoperability and secure use of many devices, not only in a smart home, but extending beyond that. I want to thank all of our partners and our sponsors in terms of your time, your investment, resources to make this event happen and make it full of rich content, both from NXP and from our partners in partnership with NXP to bring very innovative capability in the tech lab as well as in the lessons and the teachings that'll take place. So, building a world that's better, safer, and more secure. I'm going to discuss 3 application areas that are listed here. And we're going to talk about the problem and the challenges associated with those that leads to opportunities. Have some discussion about the topology of what is involved in forming a solution to make meaningful differences in these application areas or market segments. Then talk about how NXP is evolving towards more system solution thinking. And what we mean by that is understanding the problems you need to solve, not tactically, but long-term strategic needs to address the evolving market with the content that is coming in from semiconductor technology and how to leverage that to differentiate your products. When we think about the world, which I call the age of edge computing, the proliferation of more and more devices that depend on semiconductor content to accomplish the functionality, the capability, as well as the impression of the brand, the number of devices is increasing dramatically. In each one of those devices, to accomplish the capability it's necessary to be competitive, the content is also increasing. More devices, and in a device, more content. And then the end capability of that system with all that content leads to a dramatic increase in complexity that you have to manage. Creating intelligent devices sounds good, makes a good marketing chart. What does that mean? Building machines that can anticipate and automate, that can understand the context of the environment around you in a given space or application area, retail, home, factory, hospital, and then determine an action that needs to occur. Performing that action independent of human instruction, independent of human involvement, but accomplishing and taking an action that's consistent with human desire. Doing it in a way where it's easy to use and easy to fix. Addressing issues around aging populations to change quality of life. Addressing climate change and the needs to achieve both your business and society sustainability goals in bringing energy efficiency and interaction and operation of multiple ecosystems around electric vehicles, microgrid management, usage within your home when they all come together. We also face challenges in the availability of resources for our business to run. Technology can come in and make operations more efficient, can offset and address some of the risks to your business by bringing in technology to perform functions that can easily be automated. In addition, we have a higher level of complexity, a higher level of software, a need to continuously upgrade, maintain, and enable functions over time. In some areas, that's commonplace. But in many of these applications, it's never been done. More mechanical, less electronics. That world is changing. Our ability to make all these devices work together is becoming more challenging problem for us. And then on top of that, We add some business and technical, because it's not a business issue, it's a business issue that leads to technical challenges such as continuity of supply and resilience of supply. It puts a burden on engineering teams in order to enable options, in order to achieve plans of your business. All tying together. The world around us is filled with complexity. You have to solve all these problems that are floating around. Some of these are siloed in a company. Different people have different responsibilities. They focus on different pieces. But in the end, you have to solve them all. You have to come up with a way to address all of these challenges. And the way that NXP thinks about this is vectors of technology. How do I sense the environment, collect relevant information? How do I compute or think and determine what do I do with that information that's meaningful? How I then connect to the environment and ecosystems that are relevant for that decision? And then how do I take action, both real time and action that's more rich in content and nature? Real time, a key aspect of what NXP has done for decades and is a key part of optimization combined with different consumer experiences such as user interfaces is key. Doing it safely and securely and creating platforms for many of our customers around the world to develop and scale capabilities to meet their business needs. Taking these vectors of technology and then bringing them into application-specific content. Moving from selling you a part to becoming a semiconductor advisor, partnering with you to understand your problems and coming up for innovative ways to create a system solutions of multiple parts across those technology vectors, bringing together application capability, ability to develop it efficiently, and create meaningful end-use experience for business and the end user. NXP is investing in several areas in order to drive solutions that take into account system-related understanding and bring it back to meaningful content from a semiconductor offering perspective. And I'll touch on how we're going about that. We're creating working groups, cross-functional, cross-product, cross-technologies to focus and develop capability that's relevant to address strategic long-term needs. We're working to modify how we bring that to market in a very effective way, how we spend time and engage with our customers at all levels, because as I said, problems are not just an engineering problem. Problems are a procurement problem. Problems are a business problem. Problems are financial, a CEO vision problem. Working together on how we bring this to market and evolve ecosystems. Ecosystems involving mobile secure credentials, integration of technologies like UWB that brings in locationing. I can tell you who you are, where you are, within 10 centimeters. And then I can have that interact in a device all of you are carrying around with devices around you. And then you get into a really creative set of use cases and how do you integrate that into a system in a way that is meaningful, easy, and is broadly adopted in the industry. Between our networking business, our mobile business, our auto business, and our industrial and IoT business, technologies are blending together and those different environments are interacting. So let's start with smart factories. Problems, challenges, and opportunities. 18% of the world's GDP is associated with the manufacturing sector based on 2021 data. $17 trillion. Huge. 1.5 trillion. Wasted time. Unplanned downtime costs every year. Imagine if we can get half of that back, a quarter of that back. Huge savings. 38% of the energy consumption from the industrial sector. Our sustainability goals, our ability to make factories more efficient, farming more efficient, bringing in techniques in order to create a more self-sufficient infrastructure, such as smart buildings, smart factories. Huge opportunity in terms of our sustainability goals to make a greener, healthier world. Waste reduction, 50% coming from the industrial sector. Opportunities to eliminate waste, waste in terms of loss of water, waste in terms of using materials in operation that is just thrown away. When we think about the basic needs in order to address some of this within the smart factory, a backbone of the solution for the system is compute. I've been doing compute all of my career, working on low end and high end. Many of you are very familiar with this. NXP has one of the broadest ranges of compute capacity on an ARM-based platform. We go from single DMIPs at the low-end MCUs, we scale up all the way to hundreds of thousands of DMIPs in network processing, application processors, and new automotive vehicle computers. And we have capability that is real-time and rich in content, and we have the combination in different forms of compute, of integration of that capability. Crossover MCU. We've introduced that a number of years ago. Most people thought we were crazy. Why do you need a gigahertz real-time controller? Well, we've took advantage of bringing a controller into a CMOS technology without the disruption of integrating embedded flash, which has its impact both in technology node availability as well as attributes of the technology. We leveraged integration, we leveraged high performance, we leveraged putting on-chip memory at larger sizes for critical real-time tasks, latency critical tasks, and we gave external non-volatile memory through standard interface like a QSPI in order to expand memory needs. And then we started to integrate into these application-specific optimization. Smart factory. This is a key building block for a scalable platform that has efficient computing, where you have choices of higher performance and real-time, secure, lower power, power-efficient computing. We have connectivity capability that takes in legacy protocols and also manages new higher throughput protocols with integrated MACs and switches, leveraging our networking expertise in terms of time-sensitive networking, managing critical tasks on a time-deterministic basis so that when something critical needs to be done, it is done at a priority in a fixed time so that you know the operation will occur safely. TSN. We've combined this with our highest level of security that comes from our payment leadership. Secure credentials, mobile wallets, secure documents, secure payment. So all have NXP. We've taken that both in a discrete forms with secure elements and also integrated in a number of our products, secure enclaves. We've combined that with our automotive expertise in terms of safety, and where the factories and the industrial safety and the automotive safety requirements are starting to converge and bringing that expertise in. This is the key building block to connect factories together and build off of it in a system solution. You can combine it with an iDATA X9. You can create a user interface, an application platform where you can optimize your factory automation based on a set of controls that are connected through this network chip and then extended. You can choose MCU-based or application processor-based vision control. You can optimize to the ultimate level of fit for purpose. You can do vision inference, classification on an MCU in a factory in a very cost-effective way. And we'll talk more about that. MCX, the next in MCUs. We had crossovers. We've enhanced those. MCUs, we're now bringing more acceleration, more function into what was a classic embedded flash MCU and controller. And we're now bringing in tiny ML, optimizing workloads. We have a demonstration of MCX handling object tracking, motor control, display functionality, and camera-based facial recognition of, in this case, 2 individuals on a single MCU, just an MCU. We enable that with the development environment. We build off of what we've done in terms of MCU Expresso. We add to it a machine learning marketplace, intelligent edge, EIQ. We bring in both capability to develop models from your data, bring in models, optimize them, and deploy them. And we work with partners such as Ozone in order to bring both defined ML packages or with other partners in terms of IoT cloud partners or other cloud service partners where you can bring in machine learning and deploy it in a development environment to help drive efficiency and efficient compute. We combine that with an analog front end that's configurable from a software perspective. It has the ability for sensing multiple sensors. You can go voltage, you can go current, temperature, resistance. It allows for factories to reconfigure with self-calibration, bringing in new sensor types and reconfigure in a very quick with very little certification requirements. And then enhancing accuracy, precision, and data acquisition so you have a much finer granular control. Combining that together in building blocks, including power management and connectivity, to build a framework of driving factory automation on a common software platform with a set of pre-validated products working together to accomplish key use cases in the factory. Smart home. Smart home's going to have 2 billion devices shipping 2027. The challenge of all these devices is how they work together or don't work together. Are they easy to use? Do they do something relevant? Some of these devices, you say, I never want in my home. Some of them, when we demonstrate that we do meaningful capability, cut your electric bill in half, make your family safer because of the technology, improve quality of life, then it becomes more and more adopted. The challenge we face is a historic, fragmented ecosystem, different manufacturers producing interoperability in very limited ways, NXPs working together with key industry players and CSA to address establishing a common language, common security standards, leveraging a mesh-based, both thread and a Wi-Fi based system for these devices to work together. Matter, the interoperability standard. A lot more discussion to be had, white papers that we have to describe how we're enabling it. We're enabling it not just by participating in a standards body. We are enabling products, which I'll talk about. We are enabling ecosystems to allow for device attestation, to give an identity to a device, to validate that it's trusted, to allow an environment to enter into your space where you want to protect your personal assets, and to remove devices in a very effective way. Coming up with a common standard on how to communicate together, common language, and security around how those devices are given their identity. When we look at the topology of how this is set up, you have a set of end devices that perform a function. You have an aggregation of those devices in terms of border routers and edge processing functions. And then you have a set of controllers that are managing a larger area within the home and devices. NXP is enabling products, which includes power-efficient, narrowband MCUs. Some of our customers are leveraging with extremely innovative products with long battery life for smart lighting, air quality, camera security, and innovative control mechanisms that leads in the industry based on how they've optimized their system, working together with innovation partner with NXP. You combine that with our integration of compute and connectivity on a tri-band radio with the MCU integration, with performance levels tuned that is tailored towards the given application space. You don't want too much performance and burn power. You want efficiency, fit for purpose. And then higher end performance with our standalone tri-band and combining it with our MCUs and our applications processors to perform a wide range of functions in your home. I can tell you there are many, many, many devices that come into the home that have NXP inside and are being enabled to perform all of those functions that were on the prior chart. And we're doing this to enable ease of use, ease to fix, relevant and meaningful end results that not only the businesses leverage for their products, but the end users see the benefit in affecting many aspects of their life and their community that benefit from the technology. Automotive. The third one I'm going to talk about. Vision Zero. Vision Zero, the concept of eliminating fatalities and severe accidents, but not just from a technical point of view, but also a mindset at an ecosystem and a system view, in a sense. Humans are going to make mistakes. Let's take that into consideration and plan that as an expected outcome. How do I then take that and translate the solution into a more robust solution that in the end prevents more fatalities and injuries? Combine that with the sustainability initiatives of electrification. The rapid adoption, accelerated beyond anyone's model, of electric vehicles and fully electric vehicles, or BEVs, requires more semiconductor content, different control mechanisms, and then drives topology changes, including the revolution of electronic content in the car and the need to address upgradability and maintenance of that system over time. And it's not your cell phone and it's not your PC. It's a vehicle that has a safety aspect to it and a driver experience that needs to be managed that is most critical, combined with how you determine what to do and some of the cool content you can play in your car. It's moving fast. It's got layers. We talk about a software-defined vehicle. We talk about a compute platform, which I'll discuss in more detail, and you'll have a chance to explore in the various classes and forums. We have networking. We have propulsion, the driver experience. Okay. You can determine what to do. You can give interesting information. But in the end, controlling the motion, the dynamics, the result of the car through a driver's experience, a feeling, and a response is a key part of where NXP focuses, including with the electrification, optimizing battery and power management, and not only doing it with the car, but how it hooks up to your home, how it works with the infrastructure, and how you use all together in a very efficient way. Combining that with sensing, radar capability. NXP is a leader in radar. We have monolithic solutions that have high performance for longer range, higher accuracy, which also gives higher accuracy in shorter distances, so that you have higher confidence in what you're determining is a concern to then prevent. The evolution of that to 4D imaging radar. Potential replacement, we have data, very compelling, for LiDAR in terms of some of the functionality, which if successful is a system reduction in terms of cost of ownership of bill of materials. Coherent radar, fewer sensors, but still leveraging a coherent radar capability in order to get the field of imaging broad so that you can perform the task in a more efficient way. Combining that with aggregation of radar data on a common platform with our S32, with our S32R, such that you can optimize the system. Combining that with user interaction, car access, telematics, radar, digital radar supporting single chips, supporting different standards. And then finally, development efficiency. Common software platform, the growing software costs to develop and the ability to then manage that platform for new business models, configuring a car later after the purchase, maintaining it with firmware upgrades, enhancing it over time, augmenting capability based on understanding anomalous behavior and being able to download an adjustment so the user experience is extended in a positive way. All things NXP is working on in order to create this capability. It is changing the topology of the vehicle in terms of how electronics are distributed and optimized within the vehicle. You have endpoints again, zones. You have zone aggregation capability. You have higher levels of computing, and you have a vehicle computer. Vehicle computer is not a high-performance machine that's going to help you crunch numbers. What we're discussing is high-performance, real-time processing that is managing the physical motion and control of your vehicle. Doing it such that you have high confidence what you decide to do is done and the user experience is positive and it doesn't lead to a problem. Doing it so that you can scale and have common IP blocks, common software, common ways to reference, common ways to upgrade, all linking towards a S32 platform that scales across low-end nodes with the K1 family, higher performance K3s and K5s for aggregation and performing higher performance functions, radar aggregation and computing, vehicle computers around zones, and managing the traffic, the data traffic that's increasing in volume and complexity and conflicts. At the same time, you need to maintain safety, integrating time-deterministic capability comes from our networking. Security to protect someone from hacking comes from our mobile. Interaction with the car, with UWB and our mobile ecosystem that we built out. Building a scalable platform with supporting software and virtual models in a development environment where you can develop software and platforms a year ahead of the platform and hardware being in place. Doing it with power efficiency, both for the vehicle computer, including the PMICs, and the analog that goes along to optimize the system, to deliver scalable and reuse of applications, to start to address software, efficiency, early development, time to market, to enable a future vehicle that needs to be upgradable and configurable. Changing goes against some of the past 20 years I've been involved with automotive in terms of what can change and what can't change. Much more dynamic system that needs to be managed. So with that, we're going to start to shift to our live chats and go from NXP to real-world examples of how innovative companies are changing the world, making it better, safer, and more secure. And we're going to start with the concept of productivity of a factory, but applied to a factory in the field. Elimination of waste in farming, and how to reduce that in a way that's meaningful to the business people and to society. And then leveraging automation in terms of autonomous vehicles to perform a function that's needed in a given space.
I chose the name Blue River because I really think that our technology can make rivers blue. Imagine a world where farmers don't spray their fields. They just spray individual weeds. And by doing that, we can reduce the amount of herbicides that get sprayed by 90%.
If you were sick, you wouldn't give an antibiotic to everybody in the building, right? We'd just give it to you. And same for plants, right? We should just give each plant what it needs.
This is the very definition of sustainable farming. Economics for the farmer and good for the world.
Blue River is incredible in terms of their capability to develop, computer vision, deep learning models to advance precision agriculture.
What we're doing is we're putting cameras on sprayers, and those cameras are connected to very fast computers, and they're able to figure out which plants are crops, which plants are weeds, and spray only the weeds.
John Deere and Blue River are the perfect fit.
Our technology couldn't work without their technology. We're working on computer vision and machine learning, and John Deere is creating the most stable boom that exists in any vehicle platform by using new materials and designing it for the ground up.
There's a real purpose to the innovation here.
What I love about Blue River and John Deere is that it's not just about using this great technology, it's using this great technology for a really good purpose, helping feed the world and helping protect it.
So please help me welcome Jorge Herrad to the stage for a chat, Vice President of Automation and Autonomy.
Thank you for having me here.
Thank you. Very inspirational video about what you're doing in terms of changing the whole idea of what farming's about. So can you quickly tell us about more detail on the technology and how it's impactful to the farmer and to the food production?
Yeah, absolutely. So food is one of those things that we need. Our species, our world depends on creating food, right? It's not this thing that is going to be revolutionized, upended by the cloud. It's not going to be disrupted by the web. It's something that is here to stay, and we need to do it, and we need to do it well. So what we're doing is we've created this machine that is now starting to ship. That is a sprayer. It's 120 foot wide, and you can imagine that's from that wall to that wall, 120 foot wide. And we put 36 cameras, very cameras that are looking at every single square millimeter of the ground, and we put them about 1 meter apart. And they can see every single plant that is growing. They can see weeds that are as small as your nail. That's the size of the weed we can see. And we're looking at them from the boom of that sprayer. And as the sprayer drives at 15 miles per hour, which is very, very fast, it can spot those weeds. And before the boom gets to it, we activate the sprayer and we spray only where the weeds are. By doing that, we end up spraying only about 1/3 of what you would normally spray. That has big implications of saving and waste. It has big implications of saving in dollars for the farmer. It has big sustainability impacts, and it makes for better food.
Yeah, and as you just said, I mean, one of the biggest expenses for a farmer is the materials that they use, and you just save them 60-some-odd% of their costs from an operational point of view, and you give them a whole set of data for them to manage their farm, which is really cool when I got to tour and see how you were creating the digital twin environment as well. And just before you comment, cool technical facts. 15 miles an hour, I think 1.2 billion pixels per second in order to then see and spray. Sense, think, act, right there.
That's absolutely right, and connectivity is also important in that. Yeah, absolutely. So we're making all that work with a lot of help from NXP, and we're incredibly happy that this is a good product that is saving farmers a lot of money. A large farmer would be spraying somewhere around $200,000 worth of herbicides, and again, we can cut down by a factor of 3.
Yeah, and think about the environmental impact of that as well when you cut back that usage. But also what's really cool about John Deere is your autonomous tractors. And I love the tractors. I have my green and yellow hat and a really cool cockpit with displays, as well as knowing location, which is critical in the autonomous tractor. Can you give the audience a bit of perspective on what you're doing in that space?
Yeah, absolutely. So self-driving, my opinion is that using self-driving in off-road applications like agriculture is the perfect place to start. Right? There is no humans, no other vehicles. Accidents are common because people fall asleep driving a tractor, and it is a dangerous activity. We allow tractors to operate fully autonomously. This means that the farmer can drive the tractor to the field, leave it in a corner, get out of the vehicle, swipe right on his phone, and the tractor will go and completely autonomously, using GPS and using cameras, will drive the entire field. And if it encounters something, if there's an obstacle, a rock, or I don't know, a wet patch, it will call the farmer and will tell them, hey, here's what I'm seeing in front of me. Do you want me to stop and wait for you? Do you want me to go around this? Do you want me to just continue driving? Maybe it's just a weed, and the farmer says, yeah, you can just drive over it. So we allow full autonomy. This is level 4, level 5 autonomy in the farm, which takes advantage of a number of things, including the fact that there is much easier environment than in public roads to operate.
Yeah. And I got a little bit of trouble because I wanted to turn off the autonomous capability and then drive the tractor, because it was a really cool cockpit with i.MX and the displays. And what's also cool is understanding the location and how that's critical, as well as managing the various farming equipment and their spacing.
Yeah, that's right. We use GPS. We use a very precise GPS. We use a type of GPS called RTK. that allows us to get down to 2 centimeters of accuracy. And we're able to drive very, very, very straight rows by using this GPS. Know that we're always safe and inside, when we're in autonomous mode, always safe and inside this field boundary. So we don't allow the vehicle to go outside the boundaries of the farm and just stays in there. And we augment that with cameras that are seeing the obstacles.
And the last thing that really wows me when I meet with John Deere and team is the amount of data that they collect and they feed up to the cloud, and the environment to help the farmer optimize. I've seen an entire farm field where they see every weed across the entire, and they can explain. I started to point, why do you have weeds in that location? And they start to explain the fundamental reason and what they're doing to optimize their farming. But it's amazing to see.
Yeah, no, thank you. Yeah, we are AWS's largest industrial user of data. That's how much data John Deere machines produce.
So, yeah. So it's absolutely amazing. You're making a huge difference at John Deere in terms of changing the concepts of farming, the productivity, the quality of food, elimination of waste. You're helping business people really thrive in terms of more efficient operation of their business. And I really appreciate the partnership with NXP.
Thank you so much.
My pleasure.
Thank you.
So now we're going to shift to quality of life and how you change someone's life in terms of managing a challenging condition and using technology. I've had the pleasure of working with this company, Insulet, for over a decade in terms of the types of devices and evolution of their products. So let's take a look.
You know, our mission as a company is to simplify life with diabetes. So I'm a pediatric endocrinologist. What I realized as I was in clinical practice was that I can't be with my patients every night, but I can help develop technologies so that parents can sleep through the night and for adults to live alone and not worry. And that's why I'm here at Insulet.
Omnipod 5 was 5 years in development, and I'm thrilled that it's finally out in the world and starting to change lives. There are hundreds of thousands of people who are going to think less about diabetes. They're going to sleep better, they're going to eat better, they're going to live better.
To be able to just let them live their normal lives and maybe forget about diabetes for even just a little bit, just one overnight, having one good night's sleep. That's really a dream come true for me.
I'm confident in Omnipod 5 that I can really just let it do its thing, and I can still be a mom, be a neighbor, be a best friend, be a wife, and then have diabetes.
Omnipod 5 has allowed me to sleep throughout the night, and that's the first time I can say that in a long time. My life is slowly getting back to what I was used to prior to being diagnosed with diabetes.
I'm not watching my phone constantly because I have the trust in the system that it's going to take care of her. Life is easier. It's so much easier. Life with diabetes is not easy, but this makes it much easier.
I've found this new confidence that I didn't have before. I just feel like a totally new woman who can literally do anything.
For a child that age, tubes and shots, you couldn't be a kid. As a parent, it gives you peace of mind.
He can do whatever he wants. We're excited that he can do whatever he wants.
When I get in the car and I'm driving home from work, I know that every day we're moving towards making lives better for people like my daughter. I'm honored to work for something that's helping my daughter.
Please welcome Dr. Trang Lai from Insulet, Senior Vice President and Medical Director. Welcome. Wow.
Is that a great video?
It is. You're changing people's lives. You're giving them freedom. Can you tell us about some of the technology and how that's accomplished?
Yeah, I'll just first start by saying thank you so much to NXP for inviting us. NXP has been a great partner for Insulet, and none of this would be possible without your support, so thank you. So firstly, a little bit about Insulet. So we're a company that was started 23 years ago by a father who had a child with type 1 diabetes. So he was about 3 years of age, and the father was an entrepreneur and thought, you know, there must be a better way to treat diabetes aside from giving injections and tubed pumps. So he thought of an idea of creating a disposable tubeless insulin pump. And at the time, it was revolutionary, and it still is. We are the only tubeless automated insulin delivery system in the world. And Omnipod 5 has completely revolutionized diabetes care. So just a little bit about diabetes. So there are two types of diabetes that you are likely to be familiar with. Type 2 diabetes generally occurs in adults, generally from obesity, lifestyle factors, as well as genetic factors can predispose people to developing diabetes. And there's a lot of medications out there, but often a lot of these medications don't actually reverse diabetes. So towards the end of their disease progression, people require insulin to treat their condition, and it becomes a life-sustaining therapy. And then there's a lesser known type of diabetes, one which I'm particularly passionate about. As I mentioned on the video, I'm a pediatric endocrinologist. And actually before my role at Insulet, I was practicing at Stanford University in clinical care and research. And at the time, and this was back in, 2008, 2010, the technology was really just being started in diabetes care. So real-time continuous glucose monitoring was started, and then all this technology was really just beginning. So type 1 diabetes, if you don't know, is an autoimmune condition. So people are diagnosed often without any family history. And the youngest child that I've taken care of was just a few weeks of age. And there is no cure for type 1 diabetes. And throughout my residency, I took care of, I spent a lot of time in the emergency room, and some of the sickest children that I ever took care of were children who presented with diabetic ketoacidosis, which is when they present with a complete insulin deficiency. And then for many years, we have insulin, which was discovered about 100 years ago, and although that is life-saving therapy, the insulin has a very narrow therapeutic window. So if you give too much insulin, you can cause hypoglycemia. So this is when the blood sugar is very low, it can predispose you to seizures and death. So death is a common cause of death in type 1 diabetes. And then if you don't give enough insulin, you can predispose people to hyperglycemia, and this is what the complications from diabetes is. So the blindness, neuropathy, kidney disease. So people just live this tightrope of, it's a very, very burdensome condition to take care of. And so Omnipod 5 is revolutionary because it takes a continuous glucose sensor value from products such as Dexcom, CGM that you may have heard of, or the Abbott Freestyle Libre sensor, and then it incorporates that value into our pod, and within the pod there is an algorithm that decides how much insulin to deliver every 5 minutes. And so this helps protect people from hypoglycemia as well as hyperglycemia, keeps people in range, and improves their quality of care. So that video you saw were all real patients.
Yeah, and what's amazing to me is the way Insulet solved the problem. They created a waterproof wearable device, 72 hours of insulin, 3 days of freedom. They have a system where the critical algorithms are contained in your pod, so from a safety and security point of view, They've isolated those functions, yet you interface with a cell phone as well using
Yes.
BLE, so you have also creative user interface in terms of ease of interaction. I mean, that's amazing in terms of how you came to that solution and then where you're going in terms of capability. Can you comment a little bit more on the mindset to create such a innovative and really impactful solution?
Yeah, so and I'll just share that, back in 2009, the FDA felt that automated insulin delivery was too dangerous for any company to innovate on. And so they did not allow any clinical trials to happen for this condition. So it was perceived to be very dangerous. And so what's clearly evolved over the years is that consumer electronics has advanced significantly, and to the fact that we're able to run our algorithms on these chips and every 5 minutes be able to augment that, and sufficiently such that it enables those improved clinical outcomes. Yeah. So there's one thing in having that technology capability, but then also making sure that it can function in a physiologically safe way in our patients is really critical as well. Yeah. And then, the balance is not just improved clinical outcomes, Ron, but also, the patients they don't really, no one's showing off their insulin devices, right? They want it to be discreet. They want to be able to run their apps off the phone. And so, balancing the consumer side and really making sure that our technologies are discreet, can be run off phones and apps, has been a really interesting intersection between consumer technology and med device advances.
Yeah, it's a fantastic application. I get emotional every time I see the video, and it really sets the stage for how you can give people freedom, quality of life, and leveraging technology to overcome what is viewed as barriers, and then showing that you can do it safely by innovating a system solution and a connectivity solution that really makes a difference in people's lives. So NXP and I am very excited to continue to innovate with you and to bring this to a broader set of communities and population, and really have a positive impact. So thank you.
Yeah, thank you so much, Ron.
Okay, thank you. So we talked about challenges, we talked about different ways to make the world better, safer, more secure, thinking from a system solution point of view, working with you, with our expertise combined with your expertise in a partner and advisor role where having that deep knowledge of semiconductors is meaningful to help you solve your problems. Doing it not only in the segments that I've talked about, but also how we bring communication infrastructure, grids for managing of the electric grids and usage for efficiency, mobile phone interaction, all very key. So the chairs will not automatically come up, but we can pretend for the moment. They're going to rise on the stage because they've anticipated we're at that point in the event. And we are now going to switch to our panel, and we're going to talk about technology and how it is shaping society. And I want to welcome up to the stage Junko Yoshida, who is going to facilitate this panel, as well as our other panelists who are going to come up as part of the panel session. So we will shift now into this discussion. So welcome.
Thanks. All right. Well, thank you very much for this, sticking with us. And one of the reasons that I really wanted to do this panel was that we've heard really good stories, great videos, and I'm very impressed. And I think there's a lot of hard work go underneath that to bring to the safety, bring to the, get the consumers' confidence. So I just want these people to pull back a curtain a little bit. What took them to get here? because I'm sure there are a lot of surprises, unexpected surprises, and good or bad. So I am here to talk about, well, I should actually introduce myself. My name is Junko Yoshida. I'm sorry. My name is Junko Yoshida. I'm the editor-in-chief of the Ojo Yoshida Report. I retired from EE Times 2 years ago, and my partner Bolaji Ojo and I started this publication called the Ojo Yoshida Report. And the reason I wanted to do this panel was really, this is a topic very close to my heart. There are really, a lot of publications, a lot of coverage on technology, and they're doing a great job. But what I wanted to bring to the table was really, what is the impact of technology on people and society? So that's the topic for this panel. All right, so without further ado, actually, I'm going to start with Phil, that I want each panelist to describe, introduce yourself, Phil.
Hi, everyone, I'm Phil Koopman. I've been doing self-driving car safety for more than 25 years, but I've also done safety in a number of other domains: rail, chemical process, HVAC, power supplies. I don't know, I can never remember the list. I've seen a lot of stuff, and I'm always the guy who says, yeah, that sounds cool, but did you think of that, right?
All right.
So
okay.
Jorge Herod, I'm the Vice President of Automation and Autonomy. My background is in engineering. I'm actually a computer architect by training, and been working in agriculture and helping agriculture continue in its journey of becoming more precise, more sustainable, more profitable, and more productive.
All right, Trang.
Trang Lai, Senior Vice President, Medical Director at Insulet, maker of Omnipod. And at Insulet, I lead the clinical function, which is involved all the way from product conception all the way to patient training. And yeah, excited to be part of this panel.
All right.
Okay, just add a little bit more. So 35 years in the industry, embedded compute-focused engineering is where I started. Involved running R&D organizations, running businesses, and now running sales, so selling technology around the world.
All right, so actually, I think based on what I just heard on the stage, I'm going to start with you, Trang. My question was that you said that back in 2009, FDA did not allow you to do any clinical trial based on this kind of automated, remote, insulin.
Yeah.
How did you get the approval? I mean, how did you, if there's no clinical trial, how did you bring to the point that you would convince the regulator that we can do this safely?
Yeah, so I'll briefly, because it's a long story, but essentially there were companies like Medtronic Diabetes that were investing in automated insulin delivery, and they actually had to run their clinical trials overseas. So I was based on, you may hear my accent, I'm Australian, so I did my training in Perth, Western Australia, and we were actually one of the first centers outside of the US to test an automated insulin delivery system. So this was back in the 2009-10 period. We took 2 mini-med sensors that were off the shelf. We had a BlackBerry phone. The algorithm was run off the phone. We had a translated device to convert that Bluetooth to RF and then running it off a mini-med pump. And it was one of the very first studies to demonstrate that our algorithms could run AID, automated insulin delivery, safer than a patient could. And so I would say the key thing that's made a difference over the years is patient advocacy. So, we're fortunate to work with a part of the FDA that is very patient-centric. And so, in getting products like Omnipod 5 cleared, I would say, look, it's, our data is safe, and it's much safer for people to use our product than have to figure out exactly how much insulin to give by themselves. And that creates such improvement in the burden of care for this condition, because it's so burdensome. And once people understand that, then they're like, oh, okay, well, and then, there were long discussions with FDA as to what the trial design looks like, how long do they have to be, how many hundreds of people have to be in it, what age group. So, our product needs to be used by 2-year-olds who use 5 units of insulin a day, as well as adults who use 100 units a day. And if you give 100 units to a 2-year-old, they could die. So really demonstrating, how do we manage those risks is really critical in getting these products cleared.
Yeah, I guess gaining the society's confidence is really the number one challenge, I think.
Yes.
And you can't actually convince a society or people like myself that, you can't just go out and say, no, it's safe, don't worry about it, right?
Yeah.
I mean, you have to demonstrate it is safe, why it's safe.
For sure, innovation needs to be meaningful.
Yeah.
And I mean, it can't just be smart, right? It needs to change your life in some way for you to maximize that impact.
Yeah.
And so, it's meaningful because the burden of disease is so high in diabetes.
All right, so I'm going to flip to the Jorge, because in your case, what kind of testing have you done? And before you actually allowed this autonomous tractor out in the field, tell us a little bit.
Yeah, no, absolutely. Hey, and the point you make about trust is incredibly good. It for sure applies to our products, right? John Deere has a very big brand. Farmers trust it, and one of the things that in creating this new technology, this new autonomous tractor, we wanted to create is this ability to trust the technology too. So we put a lot of thought into what if you're leaving your tractor in a field to operate autonomously, right? And you go and do another job, or you go and have dinner with your family, or what do you want to know in order to make sure that the job is getting done and getting done correctly, right? And one of the things we do is we have connectivity, so you can at any time check on your tractor and see what exactly it's doing. You can have a view of the front or the sides or the back on the job that has already been done. We have the ability to show a map that shows the coverage, meaning the areas that the tractor has already traveled, and what is the rest of the plan look like. So we put a lot of thought into what is required to enable this trust and verify that leads to trust in the job being done. On the safety side, there's several layers of safety, everything from cybersecurity to all the way to being sure that we can detect obstacles in our side. So we've been using a machine learning computer vision network. It's very similar to the approach being taken by autonomous car companies. We use convolutional neural nets, and we use semantic segmentation. We use that to detect. We have what is called test sets and verification sets that allow us to verify that our system encounters an obstacle that is enough size, it takes the right action, which is to stop.
Yeah. I'm going to ask you, Phil, that you have been working on this safety issues of the autonomous vehicle. And I don't think at this point in time, when you look at the robo-taxis going around in different parts of this country, I think there was the initial euphoria. Wow, look at this, robo-taxi can do this. And over the last 18 months, I don't think the public has that much confidence that they had the probably 4 years ago. And what would it take? What would you expect companies with big technologies like self-driving taxis, what would you expect them to do? What would allow them to actually have the confidence of the society?
It's going to take more time than anyone wants it to. And the question is whether it's going to take more time than they have, right, because of funding. But so let me give some context for that. So I got involved in self-driving car safety in the mid-90s. That was a decade before the DARPA CRAN challenge. Those were the new kids, right? We were doing it way back when. I say we, I was the safety guy, I wasn't the robot guy. But I was working with them, and there was a demo in the late 90s in San Diego with a freeway, and CMU had a couple city buses going down the highway, completely autonomous, all right? Now, it wasn't as sophisticated as what we have now, but that was a thing, and Berkeley had some, it was a thing way back then. And we learned, what we learned was the technology wasn't ready yet, is what we learned. But CMU did a drive from Washington, D.C. to San Diego, 98% hands off the wheel. And for 25, almost 30 years now, we've been working on that last 2%. That's really true. Those are the numbers, okay? And so saying we're going to wake up tomorrow and that 2% is magically going to, now maybe it's 0.2%, I don't know, right? But it's magically going to zero. No, it's going to be a really long slog out. We call it the long tail, or I think it's a heavy tail, meaning there's a huge number of weird things you have to deal with to be able to drive. Now, the nice thing about tractors is I grew up, my first vehicle was a farm tractor, okay? There's some weird stuff on a farm, but it's not like an urban core, There's just only so many weird things, and they have the luxury of saying, I don't know what's going on, I'm just gonna stop, right? But there's still some core safety things, like when the farmer comes up to the tractor, the farmer has to know the tractor's not gonna all of a sudden start moving and run them down, right? But those are the kind of things we're really good at knowing how to do. Yeah. You don't need machine learning to say off means off, right? There's stuff like that. So the issue with self-driving cars is one of maturity because it has to deal with all the weirdness. And stopping in the middle of the road, which is safe to a degree, isn't so safe when you're blocking a fire engine, right?
Right.
So it's just a really tough problem. It's just going to take more time.
Yeah. I think, Ron, you talked about how NXP has a solution for doing things safely and securely, right? Mm-hmm. Have you come across any incidents or any events that they kind of surprised, took you by surprise? You didn't expect that people would use this thing that way. Therefore, I wasn't prepared.
Yeah, I love telling a couple stories. That's more of engineering, solving a problem and discovering and creating a new problem, which is different from safety and security, but that can come into play as well. In the case of automotive, reducing weight of a vehicle to help emissions. Mm-hmm. That was partly accomplished through removal of mechanical functions and replacing it with drive-by-wire and brake-by-wire as two examples. And that user experience in the end was different from a mechanical car, which then led to a set of engineering problems and challenges to simulate resistance, or in the case of EVs, to simulate sound. So the user experience is consistent with what expectations of the consumer wants.
Right.
So I always find that interesting in terms of every step you take to solve a problem sometimes opens up a set of doors and or challenges that you then have to address. And it applies to many different application spaces where you come up with an idea and then you think about how do you then evolve it. Another one I'm passionate about is sound. And then you use sound in things such as a Dolby Atmos, where you're placing sound objects in a three-dimensional space to create an immersive capability for movies. Yeah. But then artists find a different way to give you an experience in terms of how their composition is presented to you and what instruments and sounds come together. And then you can take that and apply that to relax someone who's going into road rage, or to calm your home environment so that you have a healthier baseline such that your quality of life is improving. So always engineering results in the discovery of new engineering. So engineers, you have a long future.
There you go. One of the things actually I wanted to ask, I think it is incumbent on top management like yourselves, running the companies who produces technologies that needs to be safe and that need to be secure, right? And I think each level of design and engineering phases, there are red lines you would tell your engineering team that you can't cross. What are the red lines for Insulet, for example?
Yeah, so it's a highly regulated environment that we're in, and it's just critical that we do what we say we do per the specifications. And because the risk is so high for users. So patient safety is something that is practiced throughout the entire organization, because if our algorithm, if someone codes the wrong safety parameter and we overdose a patient, like death is the outcome. And so we think about this, all the way from product development, specifications, and how we roll out the product. And so there's just a lot in terms of risk that we think about, and we challenge our engineers to think about, look, what are all the possible vulnerabilities that can exist within our system, and how do we design that out? For example, our system relies on continuous glucose monitoring as the input to the system. So you're wearing two devices that communicate by Bluetooth. They don't communicate through body very well because of water. And so what happens when we don't get a CGM signal? What are you going to do with your system? And how do you figure out exactly how much insulin to give that is still safe for that user and not create more burden? So a lot of the early systems said, we'll just alert the user, and then people suffered from alarm fatigue and they stopped using their devices. And so that's a terrible outcome for patients. And so we think about the user experience very much in product development.
Because that does lead to the actual safety. I mean, you can't leave it to, well, let's users figure out.
That's right. It leads to safety, trust, our reputation, and our revenue. I mean, our product is a disposable product. People pay per month for it. There is no large upfront cost for traditional tubed pumps. That's how they were charged. And so because of that, we're sort of fighting for our patients every day. And so that user experience is so critical.
Yeah. What about you? Okay. What are the red lines you tell your engineers that, at the Blue River, that you can't cross this line?
Yeah, so two thoughts. One of them is integrity, telling the truth, but beyond that, doing the right thing for the customer is one of our big values, and we definitely live by it. In addition to that, we have several products. Some of them can be dangerous, right? And we always say safety is number one. However, safety should not be also taken as a paralyzing function, right? Technology has so much ability to help our lives, ability to reduce waste, ability to make humans more profitable, more productive. So it needs to be safety needs to be number one, but does not need to be again taken in a paralyzing way, right? Okay, this is the bar we want to hit. This is the bar we need to hit. Let's go and hit that bar, right?
Yeah.
That's the way that we approach it, and but it shouldn't be that right. There's a lot of accidents, for example, in roads. There's a lot of even in farms, as I was saying. There's accidents. People fall asleep and fall into the ditch, right? So it's removing that farmer out of the cab is just by itself, not having to drive that tractor, has a tremendous positive impact, right? So let's make it safe. Let's put our bar. Let's assign it. Let's tell users how we do it. In addition to that, we complement our technology with I'll call it more traditional ways of approaching things. We have lights. We have alarms. We have ways of alerting people that we're operating autonomously.
I think the situations are a little bit different between, if you compare the medical devices with the agricultural equipment. But I think there is, what Jorge just described is a classic case of balancing safety and performance, right? And I think that's something a lot of people talk about. And I just feel I want you to kind of chime in here because I recently read your technical paper for the, is it called IEEE 4000?
It's IEEE Design and Test, and we talk about the IEEE 7000 ethics standard, yeah.
Okay, so tell us a little bit about that. You actually introduced the concept of PUMA. What is PUMA?
Okay, so PUMA, prohibited utility maximizing action, yeah. That's so we just made that up. Let me tell you what it means, because so I'm co-authoring with a lawyer. So here's an engineer co-authoring with a lawyer. You can imagine the kind of discussions we have. He's a cool guy. I'm enjoying the collaboration. And one of the challenges he gave me was, hey, IEEE 7000 is an ethics standard. It's really ethics in AI, but it's really, well, it's a more general ethics standard, but a lot of it's driven by the AI. How do you do ethical AI, things like this. But it's more general than that. It's like, how do you make that actionable for design engineers who are, they're out there writing an algorithm and you want to wave your hands about ethics. How does that affect their life? They're not at the top. They're not making the decisions. How are they supposed to know? And one of the concepts we came up with is how to make the red lines Junko was talking about. And the idea of a PUMA is, well, so my co-author, Bill Wyden, used to work on Wall Street. And he'd say, the things you're not allowed to do to make money, insider trading, fraud, like you're just not allowed to do those things, the regulators say so. Well, in engineering, those things exist as well. You're not allowed to knowingly kill someone because you saved 100 other people. That's not okay, even though you saved 100 people. You can't kill someone on purpose, right? Now, I hope that's sort of obvious to everyone, right? But those kind of things. Now, that one's a little extreme. It's usually more subtle. But the question is, how do you make that actionable for an engineer? And the answer, a PUMA, is a high-level requirement that doesn't trace to functionality, but traces to ethics. For example, it's not okay to have a higher fatality rate for people with darker skin color compared to people with lighter skin color. We're going to say that's not okay. That's a PUMA saying you have this constraint. Or it's not okay to test in places where the people are poor, so they can't afford lawyers to sue you if you happen to have a crash. These are examples from the paper, okay? And it might be cheaper for the company, and they might get the testing done faster if they can test in places where people are powerless against them. But that's not okay. You can't do that. So the idea of a PUMA is, at the top level, you come up with some ethical constraints on what you should build or how you should build it. And then that gives you the requirements traceability down to the detailed things for how you design your test plan, how you test your algorithms, how you validate. It's like, yeah, I know you said you were going to save 10% overall, but sadly, even though you're saving 10%, hypothetically, to be clear, you're doubling the number of pedestrians being killed, but it's made up for all the people in the cars you're selling. That's not okay if you have a PUMA saying that's a bad idea. So the idea is not to say you can't build something. The idea is to come up with high-level guidance on what are okay things to build and what are not, and have a concrete way to drive that down to engineering requirements.
That's right.
Yeah, that's an important distinction, right? I mean, I guess people are not saying that you can't depend on technology you can't advance technology for the sake of advancing, but at the same time, it's not saying that you shouldn't be advancing technology. By all means, you should advance technology, but you have to know where you can't cross the line. The thing is, the reason why I'm bringing this up, because as a reporter, I get a lot of pitch from different companies. And a lot of them, have this first thing is that technology for good, do the right thing. And these things are, throwing around in the marketing pitches all the time. And I want people like yourselves to put the meat to the bone. What do you mean when you say the technology for good? Or the, when you say that do the right things? What are the right things? What are the things that you shouldn't be doing? So I'm going to switch the gear a little bit because I'm interested in the life cycle of products. And I think the medical devices and farm equipment is different. But I'm going to start with Tran. What's the life cycle of your medical device?
So it's 3 days, and which is short, and there's a few reasons. So part of that is so insulin. If it gets too hot, it can disintegrate and it's no longer effective. So if you infuse it for too many days, the body reacts to it. There's a physiological reaction, and then you need more insulin, and it is no longer effective. And so there's the physiological limitation of insulin. And then and it's different to a continuous glucose sensor, where it's really just a sensor sitting in the skin.
So if it is only 3 days, do you do any over-the-air updates at all?
So you can, and we certainly have that capability on the controller side of things, but the pod itself doesn't require any connectivity to run those algorithms on it. So, you know, we want to make sure that, you know, it's not reliant on any connectivity. So it's 3 days, and actually Ron mentioned it's waterproof, and so the top housing has to be really secure in order to protect the electronics and everything that runs inside of it. And so, and these products need to be sterilized, and so it becomes pretty challenging to reuse those products. We also have an auto cannula insertion, so there's a needle that pokes the skin and then leaves a cannula behind, and then the needle retracts and stays within the pod. And so they're not reusable at this point.
I see, okay.
But we are looking at ways to recycle. So we do recycle a proportion of the pods that we sell. And actually the hardest thing is like taking the top housing off, and like how to take that off and still you know, maintain the functioning of the products, including chips and all of that. And you know, it's a biological waste as well. So having to figure all of that out is a strategic imperative for us.
And so in your case, it's not 3 days, right? So what's the, how long does your tractor or the sprayer that you had, how long is it expected to last, and how long do you support?
Yeah, no, that's a really good question. Our tractors last for a very long time. 10, 20 years is common, in some cases more. The tractors are well built, and we make sure that they're designed to be used in rough conditions and doing a lot of work. So they end up lasting a long time. So we support them for a long time. It's common for us to have parts for over 20 years for people to be able to repair the tractors. We've been working quite a bit on making sure that not only the dealer can support and repair the tractor, but also customers that are so inclined can do it. It's been one of our big initiatives has been making sure that we are also having ways of increasing the value of a tractor. So if you bought a tractor yesterday and there's some new functionality, like for example this new CN spray that allows you to spray only the weeds, we have an ability to retrofit that into existing machines. For example, in this case, we can go down to, we released the product last year, but you can install it in tractors and sprayers that were manufactured all the way to 2017, so that are 6 years old already.
Okay, so you can actually retrofit. Okay, yeah. Do you do over-the-air updates?
Yeah, we do. So connectivity is very important for us. OTA is for sure critical, but also in some products, like for example the autonomous tractor I was talking about, having a ability to connect from your phone and see what is happening, and when the tractor encounters something, it has the ability to connect.
Okay, Ron?
I think we're...
Okay. Oh, okay, I'm sorry. I was having so much fun. All right. Well, to conclude, do you have some words, Phil, that when you think about, I think there are so many booby traps. More technology, as technology gets more sophisticated, it's harder for users to keep up, but also it's harder for companies to actually maintain. What do you think?
So we're doing the brief sum up.
Yeah.
Okay. A shocking number of products are safety critical one way or another. Our attention's on security, but safety is just as important. And so it's important for every engineer to get a little bit literate about safety engineering. Because safety engineering isn't just writing defect-free code. There's actually, you do hazard analysis, you do all these activities for safety engineering. And every engineer should sort of have an idea what's involved with that, so they don't think, well, I tested it, it means it's safe. It doesn't work that way.
All right, on that note, thank you very much for the participation, and thanks for sticking with us. Thank you.
Thank you.